Welcome back, and today our topic will be areas in a plane. And for areas in a plane, we'll be discussing specifically the area between curves. And there is a simple formula we can follow to find the area between curves. And it just says that if you're trying to find the area between curves, you just have to subtract the integral of one from the other. So it looks something like this. So if you're an area between two curves, actually let's just define what it is in the first place. If you have the area between two curves, y is equal to f of x and y is equal to g of x, these are your two curves, and you want to find the area enclosed between them from a to b. So basically from a to b, then you can use this simple integral a to b, and this is again the area enclosed between these curves of f of x minus g of x dx. So this is very simply just the area between these two curves. So let's just draw a quick diagram of what this might look like. If you have something like this and that, and you say that this is this one is f of x, and this one here is g of x, and this here is a, this is b. Using this formula on your left here, we can define all of this and find this area here. So this is what I mean when I say the area enclosed between the curves. That would be that area. So let's do an actual example with real numbers and real everything. Let's start with the area enclosed between these two curves. Y is equal to 2x squared, and y is equal to x to the fourth minus 2x squared. So before we even begin this, to find the region enclosed, you can see up here again, the limits a and b of the integral are defined by the intersecting points, which these are the points these two things intersect. The intersecting points of the two curves. So those actually give the limits of the integration that we have to do. So the first step in this problem, therefore, would be to find the points that these two curves intersect. So very simply, we can equate these two. 2x squared is equal to x to the fourth minus 2x squared. And you get, if you just take this to that side, you get x to the fourth minus 4x squared is equal to 0. You factor it, and you get that, because you're just taking out x squared. And then you can see that this is a difference of perfect squares. We all know that. So x plus 2, x minus 2 equals 0, and you find these are the 3 points of intersection, respectively, from here. So 0, negative 2, and 3 points that this curve intersects. Now, the next step would be to graph it and to get a better idea of what this curve actually looks like and what's the best way of approaching it. So let's go ahead and you can also use a graphing calculator to graph these, but we all know what 2x squared looks like. That's just, I want to, it's a little better. It's just like any other x squared curve. And then we have the x to the fourth minus 2x squared curve, which looks something like a little different. So we know our intersection points, there are 3. One is at negative 2, one's at 0, and one's at 2. And what actually ends up happening is that the curve looks something like this, within this frame of reference, of course. And so if we continue, now we want to find the area enclosed, and we can clearly see that if we shade in this area, that's the area enclosed. But we can also see that these two areas are also equal to each other. So instead of integrating from -2 to 2, we can make our lives easier by splitting it into two portions, using 0 as one of the limits, which is of course easier to solve when you're doing the integral, and just multiply by 2 at the end. So that's actually what I'm going to go ahead and do right now. So I'm going to write down the integral for this, keeping in mind which one's which. So this one here, let's just remind ourselves, the top one is 2x squared, and the bottom one here is that x power of 4 minus 2x squared. So these are the two things. And we're going to go from 0 to 2, like I said, because it'll make it mathematically simpler to solve. And then, according to our equation up here, we have to subtract the one on top, we have to subtract the two functions from each other. And f of x is always the function that's on top, and g of x is the one that's on the bottom, so to speak. So that would mean that this one's on top here, 2x squared, and g of x would be x to the power of 4 minus 2x squared, and that's on the bottom here. So if we go ahead and do that now, from 0 to 2, and we're going to subtract the 2, so 2x squared minus x to the power of 4, and it'll be plus 2x squared now because we just subtracted it, so the signs would flip. And then again we're going to multiply this whole thing by 2 because that's going to give us the entire sum of these two areas. And then we're going to go ahead and simplify this and then take the integral. So let's just do that real quick. It'll be 4x to the 4th minus 4x squared minus x to the power of 4, and that would go to, if we now take the integral of that on the inside, it'll be 4 over 3 x cubed minus 1/5 x to the 5th, using what we know about integrals. And we're going from 0 to 2, and then I have to put this in and subtract, so 4 over 3, 2 cubed minus 1 over 5, 2 to the power of 5, then minus 0, because of course it's just 0 in there. And when we do solve this out, we get 2 times 10 2/3 minus 6 2/5. That's what these two things break down into in the end. And when you solve that out, just multiply the simple math again, just get 128. Oops, sorry about that. 128 over 15. And that is actually your final integral. So the sum, this entire area over here is 128 over 15 units. Thanks for watching.